Hi, this is Jonathan Gardner. This is part of my Theory of Python tutorial series, and on this video, I'm going to cover managing attribute access and descriptors. So in the last video, we talked about creating new types by using the class statement. We talked about what the type function actually does when you're creating a new class. We talked about a special method called init init. We're going to talk about several more special methods. These are some special methods that have to do with how attributes are accessed. So as a quick refresher, there are four things you do with attributes. You can declare new attributes. And the way Python does it is you just assign a value to it and it declares that that's a new attribute, just like variables. You can also access the attribute. You can fetch the value of it. You can assign a new value to it. And the last thing you can do is you can delete an attribute. Okay, so these are the four things you can do with variables. These are four things you do with attributes. Attributes are really just a namespace that's part of an object. Okay, now attributes are a little bit confusing because of the fact that you're not just looking at the attribute space of the object itself, but you're looking at the attribute space of the object's type. Okay, and when we get into inheritance, types can also inherit from other types, and so it can get fairly confusing. Typically, what you're going to do is in your init statement, right, you can have self, obviously, and some attributes. You're going to basically assign the attributes as you need them. Okay, and so typically you'll see all the attributes for an object in the init function. Hopefully they've given you some documentation telling you what attributes they expect to be and what the attributes do for that object. But this is typically 99% of the time, this is how you assign attributes and how you start with attributes. And all the attributes you can find for an object are going to be found in its dict attribute. This is a dictionary of its attributes. Okay, that's the general case. Most of the time it works that way. Now, there are some very special cases that happen. One that I'm not going to talk about in this video is slots. That's a very special case. I'm going to hold that off until much later. I don't think I've ever actually used slots, but I've seen it used in exactly one specific situation in my programming history. And that was a situation where they were very concerned about the memory usage of allocating each of these objects. And so they use slots to manage that because they're having millions and millions and millions of these objects instantiated. That's pretty much the only time you're going to use slots. So I'm just going to set that aside for now and not talk about it for now. Okay. So in the dictionary, the object, when you look up an attribute, it first looks in the objects dictionary, and then it looks in the object's type dictionary, right? So that hopefully isn't news to you because in the last video we talked a little bit about that. Okay. There are some cases where this is not enough for you. You need to do something special with these attributes. And the cases that I can think of is you might want to cache attribute values. So you're going to calculate a value and then you want to cache that value in the attribute. Okay. For instance, like we might have an object that is detailing how tall people are, and we might be measuring that in centimeters. And if somebody wants to know how tall you are in inches and feet, then they could calculate that for you just by multiplying the centimeters by some number. But it may be useful to store that as an attribute so that people frequently refer back to the height and feet. They don't have to calculate each time how tall they are in height and in feet and inches. Okay, and obviously the issue with this is that if you're changing that height of a person, right? So if I update the person's height in centimeters to a new value, then I would expect the height in inches and feet to also change. So these are calculated and cached values. Another case that might arise is you have indefinite attributes. You don't know what the attributes are ahead of time, or the attributes themselves might actually change. Okay. And an example of this is you might have heard of something called an attribute dictionary. What it is, it's a dictionary where you can access the keys of the dictionary through the attributes. And so a dictionary like this, well, you don't know what keys the dictionary is going to hold. So you can't say in advance what attributes need to be assigned. Okay. And another case is you might want to limit the values of an attribute. Okay. In the case of somebody that is, their height is recorded in centimeters, you might want to prevent a height of 0 centimeters, or you might want to prevent negative centimeters as a possible height. Okay, and so you need some way to limit what values are stored in that attribute. Okay. The first method I'm going to talk about is a method that you'll never modify. I have never touched this method. I really can't think of a time where I might want to. And this is the get attribute method. Okay, so get attribute is going to take two parameters, self and name. So the object and the name of the attribute it's looking up. And this is like the granddaddy of all the attribute access special methods. Okay, the base class of all classes is the object. The object is actually a class itself, type, whatever you want to call it. It has a very special get attribute defined that basically implements all of the behavior that we're going to talk about following this. If you were to rewrite this and change it, that would be reprogramming how attributes are accessed for that object entirely. So I'm not going to cover how this function works, what it does, or how you can rewrite it, because in practice you'll never do this. I've never seen an opportunity to, I've never seen a reason to do this. Once you understand how descriptors work, overriding this method just seems like nonsense. Okay. There's another method too. It's called dir, D-I-R, and it just takes the object. And what this method does is it returns a list of attributes. I don't think you should override this one either. I think the natural dir is the best. Typically people don't override dir, even though they probably should. The reason why is you're using dir in a few special cases. In one special case, you're trying to do some introspection into the object itself. You're trying to find out what attributes it contains. In that case, you're probably better off reading the documentation for the object. The other case is you want to do some kind of iteration across the attributes. And in that case, the reasons why you might want to iterate across is you're trying to serialize the object, or you're trying to present the object to the user. In both cases, dir is too general. You want something better to tell what attributes you should be showing the user, or what attributes need to be serialized. There are three special methods that kind of go hand in hand, although they are a little bit different from each other. The first is getAttr. That takes the object and it takes an attribute name. And what this does is it looks up the object and returns a value. Let me get this straight here. So this returns the value of the attribute. Okay. It sounds fairly simple. There's a couple of caveats with this. The first caveat is that if the attribute is in the dict of the object, this method is never called. So this is kind of a fallback method when it can't find the object or the attribute in the object's dictionary. Okay. Let me give you an example of what you might do. So we have this class. I call it the attributor. And in this class, I'm going to define one method, just getAttr. And that takes self and the name. And I'm just going to return the name. Okay. And so an instance of this class, if I look up, let's say, the foo attribute, that's just going to give me back foo. And if I set foo to be equal to 6, and if I were to look up foo again, that's going to give me 6, because now the attribute's set in the dictionary. It doesn't even call the getAttr method. Okay. So that is getAttr. It's a fairly special method. I use it occasionally, especially with indefinite attributes where I don't know what attributes are going to exist. For instance, if I were to write my own attribute dictionary, I would define a getAttr that would look up the name in the dictionary to see what that value is supposed to be. The next special method you might use is called setAttr. This one takes the object itself, it takes the name of the attribute, and it takes a value. Okay. I used to use this a lot before there were descriptors. Now I don't use it at all. I don't think I've used it at all since descriptors have come online. The way this works is when you go to assign any attribute, whether the attribute is already in the dictionary or not, it doesn't matter. It's going to pass in the name of the attribute and the value. Here's an example of what you might do with this. So class vector3, we're going to have an init method where it takes nothing. And it just sets the vector to an array with 3 values. Okay, and we want to make sure that these values are set such that you can do like vector.x equals vector.y equals. Okay, the first thing we're going to do is we're going to convert that value to a float. So this is an example how you can limit values. If this value can't be converted to a float, that'll raise an error, which will prevent the attribute from being assigned. And then we're going to have this simple dictionary here. If the name is equal to x, then we're going to say self.vector 0 is equal to the value. And if that name is equal to y, then we're going to say self.vector 1 is equal to the value. And as you might imagine, if the name is equal to z, then self.vector 2 is equal to the value. Okay? And then otherwise, we're going to default by going up the chain to objects set attr, and really we should be using super here. We'll talk about super when we do inheritance. But what this does is it basically passes the buck to the next set attr. Okay, so it says, I don't know what to do with this, so let object set attr try to do their thing. And if that doesn't like it, it'll raise an exception or whatever. I don't have to worry about it. Okay. Okay. Now, when I describe to you how descriptors work, this will seem fairly useless. Descriptors do this much better. The last of the 3 methods that kind of go together is del attr, __ del attr. And what this does is it takes self and it takes the name of an attribute. And this is like set attr, except it's called when you delete an object's attribute. So let's say you delete object x, well, it's going to call objects del attr with self of the object and x being the name. I've never really used this. You might find some use for it. I don't really, my imagination is not good enough for that. With these 3 methods, it's fairly trivial to write an attribute dict. And there's an attribute dict in the standard library. I think it's in the collections module. I don't encourage using attribute dicts. There's a problem where the keys have to be valid names, and you run into problems if the keys are anything but a valid attribute name. So I don't encourage people using attribute dicts. All right, let's talk about descriptors. Descriptors are a fairly mysterious part of Python. They are not obvious, like you wouldn't come up with it on your own if you thought about it for a while, but once you understand how it works, and once you actually see it working in practice, you're like, oh, that's the best way to do this. Anyway, so there's this thing called a descriptor, and a descriptor is any object with the get, the set, or the delete special methods defined. And we're going to talk about what these do later. Okay? So descriptors, they have very special behavior. So if you were to create a descriptor, like let's say we had a class that has 1 or all 3 or 2 of those methods defined, and we called it the desk class, and we create a new descriptor. This behaves like a normal object. There's nothing special about it. You can edit its attributes or whatever you want to do the way you would normally do it. The interesting behavior comes when you have a class. Like let's say we create the class called owner, and I'm just going to use the pass statement just to create an empty class, and we're going to set owner's desk to the descriptor. At this point, the class will behave a very special way. When you access desk, it's going to call the get method instead of actually looking up the descriptor and returning it. However, it's not going to invoke set and delete when you delete or set a new value for that owner. So now the access goes to get, but assign or delete is still normal. And what even gets more interesting is if you have an instance of that owner class. Okay, and now instance.desk, this will instead call get, and instance.desk equals, let's say some number like 5. This is going to call set instead. and instance.desk. Oh, if we delete that, this is going to call delete instead. Okay, so that's the behavior of descriptors. Now, there is a really weird edge case where if owner doesn't have the desk defined and you assign to instant.desk, and then later on you assign owners.desk, then Python's going to look at that thing that you assigned for the attribute for the instance. That's fairly confusing. It doesn't really arise in practice, so you don't have to worry about it. On my website, I have example code that will walk through each of these cases and show you what actually happens. You can try it out for yourself too, using idle or whatever you want to use. The first of the three descriptor methods I'm going to look at is called get. And it takes three parameters. The first is self, which is going to be the descriptor itself. Then we have instance, and then owner. And sometimes owner is none. Okay. When you access the descriptor through the owner, so in this case this would be when you do owner.desk, and desk has this get method defined, then it's going to invoke the get method with the descriptor as self, and then instance will be owner, and then the owner will be none. Okay, so that's how it invokes if you access it through the class. If you were to invoke it through the instance, then it would call get with the descriptor as the self, the instance would be inst, and the owner would be that owner class. Okay. Now, note, it's not telling you what name this attribute was accessed through. And in practice, when you're using descriptors, you have many instances that share the same base class. And so this same descriptor is going to be shared between all of those instances. So you need some way to remember what the name of that descriptor is through the class. And so typically on the descriptors, you're going to set some kind of name attribute. And there's actually a special method called setName that will help. You put setName on the descriptor, and when you assign the descriptor to a class, it'll tell you what name that descriptor was assigned through. The get function itself should return a value. That will be the value for that instance's particular descriptor. Now, in the case of the class, you could return itself. You could return the descriptor itself, so it looks like that descriptor is actually an attribute of the class. But typically, we don't do that. Okay, and if you can't return the value for whatever reason, you should raise an attribute error. Okay, which will cause the right fallback. We might call get adder or something like that. Okay. Typically, we use get if we want to cache a value. We want to remember a value that we've calculated for a particular attribute. We also use it like if we're having an object that represents a row in a database, then the value of the column of that row will be an attribute, and we'll use a descriptor to remember that value. And so the first time you fetch it, it's not going to return the value because it doesn't know it yet. It has to go to the database and ask first, and then it'll cache that value and then show you that value. There are three descriptors that we'll look at. One's called property, the other is called class method and static method, that we'll cover that have special get behavior. We'll show how that works in a minute. The next descriptor method we'll look at is called set. And set takes self, the descriptor, the instance that's either, no, that's the instance of the class that you're assigning to, because if you assign to a descriptor that's part of a class through the class itself, it's just overriding the value. And then finally, the value you're trying to set. Okay, so set is called when you have the instance and you assign some value. Okay, and this method is called here, where the instance is that instance and self is the descriptor. Okay, so typically this is used if you want to limit the values that you can assign. We typically keep the variables as an attribute on the instance itself. So let me give you an example of what this might look like. So let's say we have some descriptor with the set method, and we're going to have self instance value. And what we'll do is we'll take the instance and we'll look inside of its dictionary, and we'll look up the parameter, the dictionary that starts with an underscore plus the name of this thing. Okay, and we're going to assign that, let's say, to an integer of that value. So we're going to force that value to be an integer. Okay, and the way we might use this is we have an owner class. We'll say foo is that descriptor, and foo's name is going to be equal to foo. Okay, and then when we have an instance of that owner class and we say inst.foo equals 5, then this method gets invoked instead, and the instance's underscore foo attribute is set to that value. So you can actually look at that. You can look at what instance underscore foo is, and that should give you 5. Okay, and that's a way that you can use that. The next special descriptor method we'll look at is called delete. This takes self and the instance. It doesn't take any value or anything like that. And this is called when you delete the instance's descriptor attribute. Okay. Now don't confuse this. This is delete. Don't confuse this with del. Del is a special method that has nothing to do with descriptors. Okay. This is delete. Okay. There's not a lot to say about this. You might feel inspired to write one for a particular reason. I can't think of a reason to write one. I'm sure people have found occasion to write them in the past, and when you do, it's pretty obvious how you do it. Okay. And last, let's talk about set name. So set name is going to take self, owner, and the name. When Python creates a class and it sees that that class has a descriptor as an attribute, it will invoke set name on that descriptor with the owner being the class and the name being that name of what the descriptor was assigned through. Okay, so it's a really useful property. You might find an occasion to use it, but if you do anything but set that name through the structure of the class, like if you say owner.desc equals a descriptor, this won't get invoked. Okay, you have to set the name explicitly. At this point, I want to mention the 3 built-in descriptors that you'll see a lot, and I'm going to use them in the decorator syntax. So the first one is static method. The next one is class method. And the last one is property. Okay, what static method does is it decorates methods such that it doesn't pass self, it doesn't pass class or anything like that. So you can have, let's say, class foo, and then you have static method, and then you have def foo, and then you just have one parameter x. You can like return x times 5, right? And so if you did foo.x, I'm sorry, you need to pass in something. Foo.x of 7 and foo, an instance of foo.x of 7. These will invoke the same method, just calling, let me scroll that up there, just calling foo with that 7 value and not passing in self or class or anything like that. And the way it does is it just changes the bound method such that when you invoke this function, you're only passing in that one value and not self or anything like that. And class method does something similar. If we did class method on that foo, we would first pass in the class object, and then we'd do something there. And so if you call foo.x and you pass in some value, it's going to pass in the class as the first parameter, and then the value you passed in as the next parameter. And if you take an instance of foo and invoke the x method on that, it's not going to use the instance for the class, it's going to use the class as the class. Okay. And lastly is property. Property is very special. So what you do is you say property, and you decorate a function, a method with the same name as the property. You're going to have self in there. So we might say return self dot underscore foo. And then if you do foo dot setter, using the decorator syntax there. Then you can define another method. This is foo, self, comma, value. And then we'd say self dot underscore foo. Let's say it's an integer. Okay. And then of course there's foo deleter as well, if you are so inclined to define that. We'll just say del self, my handwriting's so bad, I'm sorry, underscore foo. That's how property is used. Property is pretty useful. I use it a lot, especially if I want to change how the object is accessed, especially if I want to do caching of some value. You just do property and a method that defines that attribute, how it behaves. Okay. And the setter is, as well, if I want to control how you set values for that property, same thing. This is basically all you need to know about descriptors in Python. There's not much else to mention. Again, there's slots. I might do a separate video on when you actually use slots. I've only seen it useful once, I mentioned earlier in the video, so I'm not going to cover that here. But I wanted to thank Tony Lee for supporting my videos. And I actually tried to speed up the development of this video because Tony Lee mentioned that he's more interested in the Python videos. So I'll try to get more Python videos coming out more frequently. Guys, thank you for your support and all the help that you've given to this channel by sharing and liking and by watching the videos. And I hope to see you next time. Take care and bye-bye.